Hey everybody, welcome back to my channel. I'm Brahm from Learn with Brahm, and today I want to show you a code that I made. So recently I've been getting into programming, specifically Java programming, and I haven't found much accessibility online to find the roots of a quadratic equation. I know tools exist out there, but I want to test to see my coding skills and just have it accessible on my laptop without, requiring the internet. So that's the reason why I made this code. So I'm going to get into how I made the code. Maybe if you wanted to try and see yourself, if you wanted to try Java programming, this could be maybe a little bit more intermediate. But if you want to do something like that, I could show you how you could do that. I also made this application into an executable file, so you do not need an IDE or like some sort of Java compiler to run this. It's a standalone application. So at the end, I'll show if you wanted to download this yourself, I'll show you how you can do that. Let's jump right in. So before starting any Java project, we need to think to ourselves, what information do we need from the user, and how are we going to get that information? So at the top of my program here, you can see I have an import, and that import is for JOption pane. Now JOption pane is used in like a variety of programs, but for the context of this root finder program, we're simply going to be using it to provide a text box where the user can read our question and where they can also give us the input. So that'll be like a little text box there. So I named the program root finder. It can be named anything, and this is our main method. So your computer will actually run everything past this point. This stuff is just basically information for the computer. Okay, so now we need to initialize our variables. So any data that we get from the user, we need a place to store that. And we use that using variables. You should probably already be familiar with this, but if you're not, this is just a quick recap. So we initialize our variables A, B, and C here, and we actually give them values, and you'll see why a little bit later. So we have A, B, and C, those are our numbers in the quadratic equation, and then we'll also have our answers, which will be the root 1 and the root 2. Now, in not all cases will we be using both roots, as we'll see later, but we need to at least have two, just for precaution. And right below it, we also need to initialize our Boolean values. And basically this Boolean is going to help us ensure that whatever value comes out of A, B, and C is the type that we want, which is basically going to be a double or an int. Because if the user enters something like, I don't know, the letter A, it's not going to read that as a number and it might crash. So we need to make sure that it's proper. So that's how we initialize them here. So the very first thing that will pop up is we're going to tell the user some information. So we're going to tell the user that this is a quadratic root finder. The format is ax squared plus bx plus c, where a is not 0. So now that we've given the user this information, we'll be able to ask them for what a is, what b is, and what c is to give them the roots of the equation, or basically what are the values of x. Okay, so here is the loop, and this is going to be the loop to get the first one, or to get a. So now we're going to say while a boolean is false, but we've already initialized up here that a boolean is false. So we're going to this is going to be the first thing that's going to run. So we're going to try this section, and if it doesn't work, we're going to put this section. Okay, so what are we exactly trying to do? So we're trying to get the value of a. So we need to ask the user to give us the value of a. So we enter here, enter the value of a, and we're simply storing that in a place called input a. That's all. And now, after the user has entered some value, whatever they give us, if it's null, we're basically just going to exit the program. Meaning, not if they enter 0, but if they enter like cancel or they don't input anything and they just leave the program, just to safely exit out of it. Okay, so let's say the input wasn't null. Let's say the input was let's say it actually had something. So what are we going to do with that? So we're going to take input A and we're going to parse it. So what parsing is when you take a literal string value and you convert it into like like a certain type of variable that you want, in this case a double. So we're going to parse input a as a double, and we're going to store it as a. So this is the actual, that's why up here we initialized a. That's where this a comes from. So now we have what a is. But the problem is, what if somebody entered a like a non-integer or a non-number value? Like let's say they entered hello into the text. Well then you can't technically parse it as a double because it's not even a number. So that's why we have the catch down here, and we save and we put it into like a variable e, and it's an exception. So it catches anything, any errors that we get, and it's going to store it in this e, so we don't have to display it to the user. And all we're going to kindly say to the user, please enter number values only. And it's going to come up here, and it's going to try this all over again. It's going to ask them for the value of a all over again. And the only way we're going to be able to get out of this loop is if they don't enter 0, and if we were able to successfully parse out the number. Meaning they gave us a successful number and that number was not 0. And then a boolean will become true. And because a boolean is now true, it's not false, meaning we can come out of this loop. So then we do the same thing for B and C, except this time B and C can both be 0, so the only thing that changes here is that we don't require input B and input B to not be 0. So again, we have B boolean is false, so it's going to try to receive the value of B. If it's null, we're going to cancel. We're going to try to parse B, and if it successfully parses, B boolean will become true and we can cancel out. If that doesn't happen successfully, we're going to ask for only number values only, and we're going to ask them to try again. And then the exact same thing we're going to do for C. Okay, so by this point, we have successfully gotten values for A, B, and C that are real numbers. So anything past this point, it's safe to do operations with these three variables. So we can multiply, divide without worrying like a character being there. So we don't have to worry about any of that. So the next part of this is to make a variable called discriminant. And the discriminant is basically a fancy word for the part that's under the square root in the quadratic equation. So that part is b squared minus 4ac. So you may be wondering, why do we need this part and why can't we just do the whole operation and give them the roots? Well, we can't do this because sometimes under the square root you could have 0, or sometimes under the square root you could have a negative number, like b squared minus 4ac could be a negative number, and the square root of a negative number, it doesn't have any real solutions. So that's why we need to do some calculations, because either it'll have 2 real roots, it'll have 1 real root, or it won't have any real roots. So we need to calculate that. So we have this operation, we do this operation, and now we see if the discriminant is greater than 0, then we can simply apply the quadratic formula. So the root 1 is minus b plus the square root of the discriminant all over 2a, and the second root is minus b minus the square root of the discriminant over 2a. The only thing that changes is here. And then we will simply print the roots as root 1 and root 2. Okay, but what if the discriminant isn't greater than 0? Well then, what if the discriminant is 0? Well then, that means it's the square root of 0, because remember, the discriminant is under the square root. So that means you're taking the square root of 0, which is just 0. So that's why we're only going to have one real root in that case, which is minus b over 2a. Because then you're doing minus b plus 0, or minus b minus 0, which doesn't change anything. So then we're only going to have one real root, and we're going to show that the root is root 1. Now this is the only scenario where we don't use the second root. We'll see that we have root 2 in case we need it, but this is a case where we don't use root 2. And it's also important to note that sometimes even all above here, when we were making sure that we have values for a, b, and c, at the beginning I said that we can do operations with this. Sometimes your computer won't trust you. So it may say it may not have been initialized, which basically means that A, B, or C, there may not be a value for them, and it will have a compile error, which means it won't be able to run. So that's why at the very top here, we had to equate A is equal to 0, B is equal to 0, and C is equal to 0. Because otherwise down here, when we're doing all these calculations, the computer may be like, well, maybe the user crashed it, or the user was able to hack into it and bypass it. So now there's no value for A. So we don't have to worry about that. And so we just tell the computer, okay, if something like that happens, just put that value to 0. Put all the values to 0. Okay, so we were here. So we print the value, the one root, if the discriminant is 0. So if the discriminant isn't greater than 0, and it's not equal to 0, then that means it has to be less than 0 in the last case scenario. So that's represented here. But if the discriminant is less than 0, that means it's a negative number under the square root, which means we're going to have an imaginary number, or the square root of -1 in the answer. And this is going to have no real roots, but we're going to show the roots with I in it. So we're going to have to split this into two sections. So we're going to split it into a real section and an imaginary section. So we have to do this because when we split the quadratic formula, this is basically splitting it into a part we know is real and a part we know isn't real. So I can show that here. Let's say we have A plus B all over C. This is basically what we're saying is that A over C plus B over C is the same thing as this. So all we're doing is, remember, minus b plus or minus the square root of the discriminant all over 2a. So we're just making this into minus b over 2a, and then the square root of the discriminant over 2a. So all we're doing is splitting it into its two parts. Okay, so that's why we need to do that. And then we're going to collect it, and we're going to compute both of them separately, and then we're going to put it back together in our answer. So up here, what I'm doing is checking what the real section is. So if the real section is really close to 0, meaning if the absolute value of the real section is less than 10 to the power minus 10, so it's really, really, really close to 0, I'm going to equate it to 0. Because sometimes it does show that if I don't put the section in, it'll show negative 0.0. So I just make it 0 just to make sure that it doesn't do that. So over here, after we initialize the imaginary section, we need to check if the imaginary section is close to 0. So basically this checks if the absolute value of the imaginary section is really, really close to 0. If that is true, then we're basically matching 0 with I, which makes it just 0. So it's going to be the real section. Now the reason we do this, and the reason I put this in, is if it's not 0 and it's not greater than 0, it could be negative 0.0001, which is still less than 0, but it's still very, very close to 0. So all this part does is make sure that if it's really close to 0, even though it's negative, we're still going to make it 0. So it's only going to have that one root again. So if that's not the case, then we're simply going to show the user that the roots contain imaginary numbers, the roots are, and then we're going to put the real section, then we're going to plus the imaginary section times I, and then we're also going to have the real section minus the imaginary section times I. Okay, so let's test this program. So I'm going to run it up here. It's going to run the main method. And we see a text box that pops up. And it says, this is a quadratic root finder. The format is ax squared plus bx plus c, where a is not 0. Okay? Now it's going to ask us for the value of a, like we had put in the code. So the first thing that we had to check is to see if the input was null. So let's first check that. If we click cancel or x, let me put cancel. So it safely exits the program. So that works. Now let's go back. Click OK. Now let me just put in, for example, hello. We see that it says, please enter number values only, so that works too. Now let's put in something real. So let's put in 2, for example. Enter the value of b. So let's say I want to exit the program now, for example. Now I could click cancel, and it would cancel. So at any stage, at any point, we could click cancel and we know it would work. So we click 2. Let's say the value of b we wanted, let's say we wanted b to be -8 and we wanted the value of c to be 6. Now we click OK and it'll give you our roots as 3 and 1. So those are the roots to this equation and we know it works. Let's test 2 more. Let's test one with 1 root and let's test another with only imaginary roots because we had implemented those as well. So next one, let's try one with only 1 root. So we'll try x squared, so we'll only put 1 for a. We'll put -4 for x, so -4x, and we'll put +4, so we'll just put 4. So we see the root is 2, so it only gives us 1 root, so we know that works. So the last one that I'm going to try is one with imaginary roots. So I'm just going to click OK here, and for a, I'm going to put in 2. For b, I'm going to put in 2 as well. And for c, I'm going to put in 5. And now we see that the roots contain imaginary numbers, and we see the roots are -1.5 plus 1.5i and -1.5 minus 1.5i. And that's it. Okay, so if you would like to download this executable file that I made of this program, I'm going to show you how to do that now. So in your search engine, you're going to put in this link. Don't worry, I'm going to put this in the description below. And it's going to just take you to a Google Drive file. That Google Drive file is going to have my root finder.exe. So if you want to download it, you can click it here. And it's going to say that Google Drive can't scan this file for viruses. This file is an executable and may harm your computer. Now the reason it says this is because it can't scan the file because it was made on my Java compiler. However, when I did this, and I can show you when I download it, there will be no viruses on your computer because I made this solely and we went through the code together. But do download this at your own discretion. I'm not liable for anything that happens to your computer if you download this and something goes corrupt anyways. So you can just click download anyway. It'll ask you where you'd like to download it. You can just say root finder. I'm going to save it as that. Click save. And it's going to save it up here. Done. I'm going to click on it. And you see that this pops up. Windows protected your PC. Microsoft's Defender Smart Screen prevented an unrecognized app, and running this app may put your PC at risk. Because it can't scan this executable again, and it's from an outside source, it's going to say this regardless. I'm the publisher. This is the app, and I'm just going to click run anyway. And it appeared on my other screen. I can drag it over and it will show the very same thing that we went over, the quadratic root finder, and everything pops up exactly the same. So that's how you download it. You can open up any files that you have and it will find up here in properties. This is the root finder. It's an exe file. Thanks so much for watching. I hope you liked this video. Have a great rest of your day.